I think what I adore most about physics is the incredible physicists who've dedicated their lives to explaining the phenomena which surround us. One such person is the philosopher John Michell, who used his Cambridge education in geology and physics, among many things, to produce some of the earliest papers on artificial magnets and seismology. But I'd say my favourite theory he constructed was that of what are referred to as dark stars, objects which he suggested would be so massive and dense light could not escape them. And if that sounds familiar, it's because the paper he wrote, which this particular theory was taken from, is actually often credited with being the first description of what we now refer to as a black hole. But what most inspires me about the theory of the dark star is not that Michell came up with it, but the way in which he did. As modern scientists, we have an equation for escape velocity, and using the gravitational constant and assuming a star has the same density of the Sun, we can show that there are values for its mass and radius, which allow the escape velocity to equal the speed of light. But Michell didn't have this information. In fact, escape velocity hadn't been thought of in the year 1783. So he thought about it in a completely different way, a very scientifically creative way, which is a real inspiration to me. See, Michell realised that the ball, whether you're dropping it, or whether you're throwing it up into the air, would always have the same acceleration. And on Earth, that's negative 9.81 metres per second squared, because the gravitational force of the Earth is always the same. And that's the idea that Michell applied to his theory of the dark star. Michell supposed a particle an infinite distance from a star, travelling towards it but starting at a velocity of 0 metres per second. He said that if the star had a radius 500 times that of the Sun, that by the time the particle reached its surface, its velocity would equal the speed of light. He then supposed that the particle was already travelling, away from the star and towards the edge of its gravitational field. He said it must be acted on by the same force, and therefore if it were travelling at the speed of light, it would never escape the gravitational field. He then supposed the particle to instead be a light wave, which he said would never leave the gravitational field, and therefore the star would be invisible to the naked eye. Alongside John Michell, all of the people and all of the scientists who've come up with these explanations, who've discovered the functions of the universe, are some of the biggest role models to me, because they're people we should look up to for their curiosity and creativity. In fact, I would go so far as to say that these brilliant minds are the aspect of the practice which truly light up my love of physics.